Okay, so here we are at our first lesson. This is 6.1, and we're going to learn about the antiderivative. So in 267, you learned how to differentiate functions. And we took the derivative and we said that was marginal analysis, the slope of a tangent line, and we called it all this different stuff, but you had to be able to find the derivative. Well, in 268, we're going to find the antiderivative. So we're going to be given the derivative, and then we're going to go backwards and find the antiderivative. Okay, and if we were in a regular class, I would put a lot of examples on the board, and I don't know, I think that just might be confusing. I just want you to know that there are 4 rules that we're going to use, and we're going to use them in every section that we cover except the very last one, section 8.2. So you have to know these rules, okay? All right, so let's talk about the definition of antiderivative, and let's just get started. All right, so I'm going to switch so I can write, and I won't ever ask you definitions, but I can't just start working problems without showing you definitions. So here we go. Okay, all right, so here's my paper. This is the antiderivative. The antiderivative, okay? All right, so if capital F of X and little f of X are 2 functions and the derivative of capital F of X is equal to little f of X for all X in the domain of little f of X, okay? Then capital F of X is this is an important word, antiderivative of f of X. Okay, so there, I'm going to stop for just a minute and we'll talk about, you will have rules, but let's talk about is an antiderivative of f of X. Okay, so let me just show you from 267 what we already know. If I said that, if I gave you a function, say x squared, okay? And what's the derivative of x squared? Well, it's 2x, right? Okay, so what I'm asking you is x squared the only function who has the derivative 2x? Okay, and the answer is no, it's not, because if f of X is equal to x squared plus 1, or f of X is equal to x squared minus 9, or if f of X is equal to x squared plus 270. All right, all of those have the derivative 2x, okay? All right, so that's why this, what we're going to do is talk about the constant, okay? So when we talk about the antiderivative, we would say, okay, so if the derivative is 2x, then capital F of X, the antiderivative is x squared, because x squared's derivative is 2x, but we call it x squared plus c, where c is any constant, just like all of these. Okay, so it's really an antiderivative, the family of antiderivatives. So in 6.1 and 6.2, after any antiderivative, we're going to put plus c, because the derivative of any constant is 0. Okay. All right, and a few of these we could probably guess. Be one. Some of the easier ones. What if our derivative was What if our derivative was 3x squared? Can you tell me what function has the derivative 3x squared? And if you can't, it's okay, because we're going to have some rules. Okay, we're going to have some hard, fast rules. But if I say, well, that's x cubed, because if I multiply down and subtract 1, I get the derivative 3x squared. But we have to put x cubed plus c, because if x cubed plus any number will have the derivative 3x squared. That makes sense. I'm going to just show you a couple more. And then I'm going to write down the notation, how we're going to figure out, how are they going to ask us to do this problem, and what are the rules, okay? So what if my derivative was just 5, okay? So what function has the derivative 5? What's the antiderivative? Well, it's 5x, and we have to put plus c, because the derivative of 5x plus 3 is 5. The derivative of 5x minus 2 is 5. So that's why we always have to have the plus c, okay? All right, and then we'll learn about differentials too, because this could have been 5y or 5z, depending on what variable we were using, but we knew what variable we were using because it said f prime of x, okay? A couple of the more obscure ones that we'll use rules for would be, what if my derivative is 1 over x? Can anybody remember whose derivative is 1 over x? It was a very small section we covered, and the answer is f of x is the ln of the absolute value of x plus c. Because remember, the derivative of an ln is the derivative of the function. So the derivative of x is 1, and we put it over the function. Like I said, we'll have rules. And then what other rules are we going to have? One more rule. It's going to be, what if the derivative is 2e to the 2x? Okay, so what function has the derivative 2e to the 2x? Well, remember, when you differentiate e's, you don't multiply down and subtract 1, okay? And the exponent on e never changes. So the derivative was e to the power times the derivative of the power. So my function would just be e to the 2x, because the derivative of e to the 2x is e to the 2x times the derivative of 2x plus c. But like I said, we're gonna write rules for all of those, so you'll know. You won't have to remember from 267. But that's basically it, okay? So if you can notice a pattern, when we take a derivative, we multiply down and subtracted 1, right? Well, when we're finding the antiderivative, we're increasing the exponent and dividing, okay? We're increasing the exponent and dividing. So how would you increase 5 by an exponent with respect to x? Yeah, it's just 5x. And these two rules are just rules of their own. So we'll look at those. So that's where we're going. We're going to look at the rules. We're going to look at the notation. But how are they going to ask us these questions? Like in 267, they said find the derivative, find dy over dx, find the marginal profit. That's, you know, there are a lot of different ways for finding the derivative. So the antiderivative, we're going to look at these rules for integration. And rules for integration and antiderivative are pretty much the same thing, okay? All right, so let's start. Okay, so the indefinite integral of a function represents the set of all of its antiderivatives. Okay. All right. So we're going to show you the notation. Okay. So if capital F of X is any antiderivative of little f of X. The notation for finding the antiderivative, okay, will be this big S, f of X dx is the antiderivative plus C. So that's a weird notation. This S is a big S. It stands for summation, and we're not going to go through the summations. We're just going to apply the rules. So this is what it's going to look like. This is an integrand, okay? I mean, that's telling us to find the antiderivative, okay? This is going to be my derivative, and dx is my differential. So you'll always have those three things there when asking a question. And this is your antiderivative plus C. Okay, and those things really don't matter. I mean, if you don't know exactly what to call them, but this is always the derivative with respect to whatever variable. Okay, so let's look at our example. And again, we haven't learned any rules, but the other examples that we talked about were, okay, so f prime of x is 2x. So if we had the integral sign and 2x, and since there's an x in it, this would be with respect to x. That's what the question would look like. And what did we say the answer was? Well, it was x squared plus c. And how come it was x squared plus c? Because if we take the derivative of x squared, we get 2x. So this is the derivative right here. And we're just going backwards, okay, and the differential. And we also said the integral of 3x squared dx. So this is what this problem would look like, okay? Of course, they have to change the notation. We're used to looking at the derivative of that prime of x, but they're going to do the integral sign. They're going to put the derivative right here with respect to x and say, whose function has the derivative 3x squared? Well, we know that it's x cubed because you multiply down and subtract 1. So it was x cubed plus c. And like I said, if you're like going, oh my gosh, I don't remember that. That's hard. I can't do this. It's okay. We're going to learn rules about how to get this answer. We're going to have 4 rules and you're going to be able to do it. But let's just go through and show you the notation for all of the questions we did before. We did the integral of 5. What if my derivative is 5 with respect to x? Then we know what? Whose derivative is 5? Well, it's 5x plus c. Okay, so now maybe you can see why the differential is important. We need to know what variable to use here. So if I had an integral of 2 dy, okay, so what function has the derivative 2 with respect to y? Well, that would just be 2y plus c. So the differential tells us what variable we're using, okay? And with the last 2 examples, we'll just wait until we get to those rules, okay? But I think you understand that this is the derivative, the differential. Those are the ones we guessed. This is the notation. And now we're going to go learn the rules for differentiation. Okay, and like I said, these are the most important rules that we're going to learn. So let's do it, okay? And I'll post these rules on Blackboard, okay? So these are our formulas for integration. Okay, so the very first formula is the integral of a constant k with respect to x. Okay, all right, so what I need you to understand is that when you took a derivative, you decreased, right? You multiplied and decreased. So now we're gonna, when we go backwards, we're increasing the power and we're gonna divide by the constant in front. Okay, all right, so this rule 1 says k is a constant. If your derivative is just a number, Okay, we're going to use rule 1. So this would be rule 1, right? And this would be rule 1. This is just a number. It doesn't have any variables in it. So how would we integrate that? It just says it's kx plus c. So we increase that number by the variable. Okay, so in our example, 5 with respect to x was 5x plus c. And 2 with respect to y was 2y plus c. So we just increase a constant by the variable. That's rule 1. That's if k is just a number. Rule 2 is the power rule, like we did for, you know, we use the power rule the most for derivatives, okay? So if we have the antiderivative, or if we have the integral sign, and a constant times x to the nth power, dx, okay? So we have, this is my derivative. Okay, so in 267, we used a constant times a function rule, but we didn't use it very much because when we took a derivative, we just multiplied down. Okay, so when we do the antiderivative, we're going to bring the constant over, okay, and then we're going to add 1 to the exponent and divide by the new exponent plus c. And this is only if your exponent is anything but -1. Okay, all right, so let's look at that. Okay, we've already done a couple of examples of rule 2 because these are functions that aren't just constant functions, right? There's variables in these functions. So it tells us in our rule to what? Let's go here and use our rule. Bring the constant over, and x is to what power? The first. So we add 1 to the exponent and divide by the exponent plus c. And see, we got our original function back. And you could write it like this or type it like this. The computer doesn't matter. So when you have an exponent, we're going to bring our constant over and we'll add 1 and divide plus c. Okay, that's not too bad. All right, 3x squared. Let's do that using our rule. And we would use rule 2 for these because there is an x to a power. Okay, all right, so what I'm going to do is when I have to integrate a variable to a power, I'm going to bring that constant in front over. Okay, and then I'm going to add 1 to my exponent. What's my new exponent? 2 plus 1 is 3 divided by 3 plus c. So I'm just going to add 1 to the exponent and divide by the new exponent. And those cancel, so you get x cubed plus c, or you could type it in the computer like this. It doesn't matter. So see, we've used a lot of examples of rule 1 and rule 2. Okay. All right. And so those are the basic rules. The rest will be E's and LNs and how to deal with these. But one thing I want to say that's really important is that you always move your variable to the top before you apply your rule. Okay, before you apply rule 2. So let's go look at a couple of examples. And we'll combine. If something was true for a derivative, it's true for an antiderivative. So when we had a polynomial for derivatives, we just take the derivative of each term. Okay, so if I had the indefinite integral of 5x squared minus 7x plus 2. Okay, so you know, what Hawks will do and what they did in 267, they would have you rewrite it, break it up, and I don't do that. I'm just going to go take each term, and I might use a different rule every time I have a term, okay? And so, well, so here, I'll look at this first term, okay? And so how do I do that? What rule am I going to use? I bring my 5, okay, and it's x to a power, so that's rule 2, right? Okay, so what is my new exponent when I add 1 to 2? My new exponent is 3, and I divide by 3. See, before it reduced, and we reduced it, but it won't always reduce, so that's rule 2. And then here we go. So I'm going to bring my constant minus 7x, and what's the exponent on x? Well, it's 1, so I'm going to add 1 to it. What's my new exponent? Squared divided by 2. I add 1 and divide. Rule 2. Anytime you have an exponent that's not -1, that's what we're going to do. But what about this positive 2? All right, so there's no variable term there, so that's just a constant term. So that's rule 1. And how do we increase 2 with respect to x? That's just 2x plus c. And that's it. So if we have a polynomial, we just apply each rule. Okay, so it's not that bad. You're just adding 1 to the exponent and dividing by the new exponent. Okay, now how is that going to get hard? Well, a couple of ways. How did it get hard for derivatives? So the integral of 3 over x cubed dx. Okay, so remember from my rule sheet that I will definitely post on Blackboard, before you apply rule 2, you always want to rewrite, moving the variable term to the numerator before you can apply your rules, okay? So I'm going to rewrite, that's RW, means rewrite, okay? The integral, and don't lose your integral sign until you actually add 1 or apply your rule. I'm going to rewrite this as 3x to the negative 3 dx. So all you do is when you move the variable term up, you just change the sign of your exponent, okay? And that's fine. So now what rule do we apply? Let's bring the constant term over, okay? And I have x to a power, right? My exponent's not -1, so I can use rule 2. So I'm just going to add 1 to my exponent and divide by my new exponent. So what's my new exponent? What's -3 plus 1? It's x to the -2 divided by -2 plus c. And do not simplify. There's no need. The more you do, the more mistakes you can make, and Hawks will accept everything unsimplified. As long as it's right, it will accept it unsimplified. So that is just more examples of rule 2. And so how else could this get harder? What do you think? Fractional exponents, right? That's what we did for 267. Okay, and that's why I want to tell you that, I mean, some people see fractions and it just makes their butt clench and they go, oh my God, I can't do it. Yes, you can. I mean, if you can't do it in your head, you can do it with a calculator. And that's why we have tools, okay? They're ours to use, okay? So let's do it. What if I have the integral of 3x to the 5/2 dx? Okay, just because my exponent is, so that was rule 2. I need to write that down so you'll know what rules I'm using. I mean, nothing changes, okay? All right, so I have, here's my derivative, and it's x to a power, and the exponent is not -1, right? So I'm just going to add 1 and divide. Okay, all right, so there are a few different ways I want you to watch carefully. I'm going to bring this constant term 3 over, okay? And then I'm going to add 1 to my exponent. Okay, so the way I would do it is I would add 2 over 2. Because, why? Because you have to have a common denominator when you add fractions, and it just makes it easier for me to go 5 plus 2 is 7. Okay, so that's x to the 7 over 2. And I'm going to divide by 7 over 2. plus c. Okay, and you can leave your answer like that in Hawks. But I will tell you this, it can get really messy and kind of hard to type in. So what is our rule? When you do what? When you divide by a fraction, you invert and multiply that by the reciprocal. So I could call that 3x to the 7/2. And instead of dividing by 7/2, I can multiply by what? 2/7, which gives us 6/7x to the 7/2 plus c. Okay. All right, so at this point, you're going, oh my gosh. All right, so let's go back and look at this problem. 3x to the 5/2. Just so to show you, I'm a math teacher, right? So I know how to do all this fraction stuff. So, so I'm going to bring over the 3x, and when I add 1 to the exponent, okay, we could do that on our calculator. So 5/2 plus 1. So I'll probably put parentheses. 5 divided by 2, parenthesis, plus 1. And you get 3.5. A lot of times they won't accept a decimal. Can you see that? 3.5. Okay, and this is what I love about this calculator. Right above the enter sign, there's this double arrow button. And if you push it, it gives you the 7/2. Okay, so 3x to the 7/2. And then if I divide by 7/2, okay, so I could do that on my calculator. 3 divided by, parentheses, 7 divided by 2, okay? And push enter, and I get that decimal, but look, I go right above the enter to that double arrow, and boom, it gives me what? 6/7. So I have 6/7x to the 7/2 plus c. So either way you want to get that answer is fine with me. You know, I'm no shame, no calculator shame. I love this because it'll make a fraction. I'll make sure you can see it. A fraction into a decimal into a fraction, you know, real easy, easier than the graphing calculator. And if you have a graphing calculator and don't want to buy a calculator, I can show you how to use that. With the little blue calculator, it's a lot harder. This is not an expensive calculator. And a lot of you already have one from 267. It's my favorite. Okay, so we've done a lot of rule 2. Okay, one thing I do want to note that sometimes instead of writing fractions, we could have x, the square root of x, and you would rewrite that as x to the 1/2 to begin, okay? Because there's no number inside that radical. It's understood to be a 2. If there's a 3 inside that radical, it would be x to the 1/3. Okay, so any number inside that radical will be converted to x to the 1/n, just so you know. Because a lot of times, so instead of giving you the fractional exponent, they'll give it like this. You'll rewrite it like this. You'll apply your rule, add 1, and divide. Okay, let's talk about the last 2 rules, and then we'll be done. Okay. So, rule 3. Well, let's just look at an example first. So what if I'm just going about my business and I have 5/x to the 4th plus 3/x. So I've got 2 terms. So the first thing I'm going to do is rewrite. I'm going to move this x to the 4th up, and I'm going to move this x up, okay? So that's going to be 5x to the -4 plus 3x. And if there's no exponent on that x, it's understood to be 1, right? So when I move it up, it becomes -1. So now we're ready to apply the rules. Well, what rule is this? Rule 2. So then once you apply your rules, you can leave your integral sign and your dx. So that's 5x. And when I add 1 to my exponent, my new exponent is what? -3 divided by -3. Okay? Plus 3x. when I add 1 to -1, I get 0 divided by 0. And I don't know, but no, can do. No, you can never divide by 0. So that's my red flag. That tells me that's why there was this caveat on rule 2. Okay, remember we said that the exponent can't be -1, and that's what happened here. My exponent was -1, so I can't use rule 2. Okay. Okay. All right, so what do we use? We use rule 3. That says if we have an integral times a constant over x dx, we have to rewrite it. That's the integral of a constant times x to the -1 dx. So again, I bring over my constant, and I know that I can't add 1 because I get 0 divided by 0. So that means it's the ln of the absolute value of x plus c. Okay. So if you recall from 267, the derivative from 267 of y is the ln of a function. The derivative was the derivative of the function over the function. Okay, so if y is equal to the ln of x, the derivative of that is the derivative of x, 1 over x. So when you integrate 1 over x, you get the ln of x. Because remember, this is a derivative and we're going backwards. And we learned this in section 5 point something at the end of the semester. And it might not have been the best time if it was last semester for you, but there we go. So let's go back to this example. Okay, so when I'd rewritten those, I said that was 5x to the -3 divided by -3 plus 3. And when I add 1, I see that I get 0 and divide by 0. So that tells me to use rule 3. Okay, so it's 3 times the ln, and you have to do the absolute value of x plus c. Okay, and when you type in the absolute value of x on Hawks, you're going to have to use your keypad for ln and the absolute value. Okay, because if you just type in the L, it won't work. Okay, all right, so that's rule 3. Anytime your exponent is to the -1 power, we're going to have the ln of x. Okay, so 3 rules. And then now the 4th rule, and they're just 4 rules, so we can do this. Rule number 4 is the indefinite integral of a constant times e to the kx dx. Okay, all right, so a constant times e to the kx is a constant. Bring over your constant, and it's e to the kx, and we divide by the number in front of x plus c. So these are all 4 of your rules, and I'm going to go talk about rule 4 in just a minute. And then I'm going to go open up the homework problems and just work them out step by step so that you'll see them. So when you're working them out, they'll be in the same order. But I want to talk about e's just like ln's for just a second over here. Okay. Remember from 267, if y was equal to a constant times e to the power, to take the derivative, we brought over the constant times e to the power, and we multiplied by the derivative of the power, right? So we're going to do the opposite. So the exponent on e never changes. So if I had said 3e to the 2x plus 1, okay, what would the derivative be? 3e to the 2x plus 1, and I would multiply it by 2, right? So that would be 6e to the 2x plus 1. Okay, so now if we integrate 6e to the 2x plus 1 dx, my rule 4 says bring over the number in front, 6, leave the exponent on e the same, okay, and I divide by the number in front of x, so I divide by 2 plus c. And you can leave it like that, or you can write it as 3e to the 2x plus 1 plus c. So this, we got back going the other way and going backwards. And these are just 4 rules that you have to memorize. And a lot of times they will be like 5e to the x dx. And so that would be rule 4. And it's 5e to the x. And we divide by the number in front of x. So we divide by 1, but doesn't change anything. It's just 5e to the x. But sometimes when there's no number in front of x, people want to write 5e to the x divided by x plus c. And that's not right. You're just dividing by that understood 1 in front of x. So that would just be 5e to the x plus c. Okay, those are your 4 rules. You can get started on section 6.1 and start all the homework and apply the rules. And I am going to work the problems live and post those so you can use them for examples. So y'all got this. We can do it. And yay. I'll see you soon.